Hello and welcome back to another one of my weirdo videos. Recently I decided to make another handbag, especially for those who really like my first one, but don't have a sewing machine. I have been saving these HDPE bottles for a while now, mainly because once you cut the top and the bottom of them, you'll end up with a nice straight piece of relatively thick plastic which you can easily shape and weld into all sorts of things. And so here is how I made the high density polyethylene handbag. I started by cutting off the tops and the bottoms of the bottles and thoroughly cleaning whatever liquid was still left on the inside. Next I printed out the template and moved on to the fun part. To make the handbag look more interesting, I decided to draw my logo onto it with a design marker. If you would like to replicate this project, I left a space in the template for you to draw your own design. For tracing, I used a craft knife. I began by placing the plastic sheet onto the template, secured it in place with a clear tape, and gently traced the lines with a craft knife. For the next step, I contemplated on using the scissors, but this cold plastic is really easy to bend and cut through with a knife, thus leaving a nicer, sharper result. To protect the design drawn with a marker, I applied a coat of polyurethane craft varnish, otherwise it would easily scratch off over time. Before welding the handbag together, I proceeded to bend the pieces along the scored lines. Most of these were Indian bends apart from the very top of the front and back pieces where the handles would be later attached to, and the top of the inner wall. For these I bent them inwards first and then outwards. For the next step, I started by uploading the coat to the Arduino and attached the header pins, so that the coat could be easily re-uploaded later. I wanted all of the electronics in the back to have a fixed position, but with the switch, charger and Arduino still easily accessible. So I decided to position the switch in the upper right corner of the inner wall, with the charger right next to it and Arduino just under the charger. To do this, I cut a hole big enough for the switch to slide through the inner wall, and I stitched the switch onto the inner wall with the needle and thread to secure it in place. Next I soldered two wires onto the switch and pushed them through the gap in between the switch and the inner wall. These wires were then attached to the positive output on the charger and the VCC pin of the Arduino. Another wire was connecting the negative output of the charger and the ground pin of the Arduino, followed by two more wires for the battery. Next I soldered the two wires for the push button onto the pin 2 and the ground pin, and 3 wires for the LEDs onto the pin 6, VCC and the ground pin of the Arduino. To make sure everything works as intended, I attached the wires onto the LEDs and the battery and shortened the push button wires. To make the soldering onto the battery easier and avoid applying too much heat, I gently filed both ends of the battery with a nail file. Since everything worked as desired, I removed the wires from the LEDs in the battery and stitched the charger and Arduino to the inner wall. The melting point of high density polyethylene is 130 degrees Celsius, so I set my soldering iron to about 280 degrees Celsius. I found this to be the sweet spot in between having to wait too long and burning the plastic. I wanted to make sure that all of the electronics in the bag would be protected from any accidental shorting, so I took a larger scrap piece and cut out holes for the USB, switch and the Arduino header. To begin the welding process, I slid the cover over the header and aligned it with the inner wall. Then I poked a lot of holes through the two plastic layers with the tip of the soldering iron to create a strong joint. Then I attached the hood for the Arduino headers. Next I aligned the bottom edges of the front and the side piece and welded along the overlap from the inside. For the side, I laid the piece horizontally with the front facing upwards, then I pinched the edge of the side piece and aligned it with the bottom edge of the front piece and welded from the outside. I carried on aligning and welding the two pieces together all the way up and repeated for the other side. Once the two sides were erected, I spot welded each tab of the front piece from the inside. When it comes to creating shapes from plastic sheets, You can pretty much treat it as a paper craft project, except you would use heat to create the bond instead of a glue. To keep the wires organized and out of the way, I cut the inner wall tabs wherever necessary into smaller strips and use those as wire fasteners. Before attaching the inner wall to the bag, I applied some double-sided tape onto the LED strip, shortened and soldered the wires from the Arduino and attached it to the bottom of the front piece. Then I welded the inner wall to the bottom of the bag and proceeded to align and weld each tab of the inner wall from the outside and then from the inside. Next I shortened and soldered on the battery wires and made a small battery cover. Upon turning on the LEDs, I found the electronics to be a little distracting, so I decided to cover the inner wall with a piece of white plastic sheet salvaged from an old monitor, stuck onto the inside of the inner wall with some double-sided tape. Once that's done, I secured the top of the inner wall onto the top of the front piece from the outside. Next I attached the back to the bottom of the bag, welded from the inside and welded the sides from the outside. After that, I cut off the protruding sides with scissors. For the closing mechanism, I decided to go with Swan snap fasteners. I cut 2 small holes on the back side of the bag for the bulging parts of the fasteners to sit in and welded on the handles to the front and back of the bag. Next I sewed on the fasteners and welded on the bottom piece of the bag. To finish off, I cut a small rectangle into the top layer just next to one of the back fasteners for the push button. I cut a few smaller strips from the leftover plastic sheet and used them to secure the push button wires in place. Next I shortened the wires and soldered them onto the push button. And at the end, I cut another small piece of plastic with a rectangular opening and welded that over the push button to keep it in place. I love how the handbag turned out. I managed to get 22 hours of continuous illumination on a 5-hour charge, but this will hugely depend on the battery itself. This bag could be used especially if you like to stand out in a crowd or as a safety measure on those walks home at night. As for this one, it will be going to my little niece because she loves handbags. I hope you enjoy watching this video and I'll look forward to seeing you in the next one. And as always, for written instructions click the link in the description. Bye!